group lunch meeting or wherever you happen to be at whatever time it is. You can connect with us on our website, dataplatformwit.com, on Twitter at data_wit, on Blue Sky at data-wit. We frequently post our sessions out there so you know when they're coming and news about different events that are coming up. And our newsletter goes out to our website. Upcoming session for next month is Critical Communication, Managing Yourself and Others by Blythe. And today's session is another brick in the firewall, how to secure your Azure Data Platform by Grace. So I'm going to turn it over to her and let her do her presentation now.
Brilliant, thank you. I will just share my screen and then we are good to go. Can you guys see that okay?
Yes, we can. Thank you.
Brill. Okay, so let's get started then. A little bit about myself before we get right into the technical. So my name is Grace O'Halloran. I am a principal data engineering consultant at Advancing Analytics. I am a Microsoft Data Platform MVP, and I have just over 8 years of experience working with Azure Data Platforms. My area of specialism although I'm, all my experiences on the data side, I've very much come up through a data route. I've sort of ended up more focusing on areas such as platform engineering, infrastructure as code, Terraform, CI/CD, and specifically security and network security of data platforms. So that is kind of my area of expertise within data engineering and data platform engineering, and especially within the community. That's kind of the bits that I like to speak about, and I will come on to that in a bit more detail as to why I think that's important. I've got my socials on here, so feel free to connect with me. I've also got a link to my community content GitHub at the bottom there. There is also a QR code at the end, but all the slides for today's talk and all the other talks that I've done are on there. I also have a blog, Thinking a Cloud, where I post various data platformy, networky related bits and pieces. There's a lot about Databricks on there recently, so feel free to check that out as well. So this is what I want to cover today. So a little introduction about why I think people should care about this topic. And then the rest of these sections I've kind of modeled on the conversations that I have with my clients. So if I'm working with a client and they say to me, I want you to build me a data platform, but I want it all to be fully secure, fully privately networked, a lot of the time they don't realize, that has a lot of implications in terms of what actually then has to be implemented, what has to be configured. And so there's multiple things I need to talk to them about and make sure they understand, and questions that I need answering so that I know how to deploy the right things for them and ensure that it's fit for purpose. So I've kind of modeled the sections over the different conversations and the different workshops that I would then run with a client who is asking me for such a platform. So we'll talk about networks in general, we'll talk about ingress and egress, we'll then touch on Azure Private Link, and then some generic data platform components that I typically work with that you may be familiar with as well. Okay, so why care about network security? I do data, why is this relevant to me? I get asked this question a lot. I think maybe more so recently, people are starting to perhaps realize that this is an important thing. But I think for me, this is something that has changed dramatically since everyone's been moving into the cloud. I think historically there was a lot of silos in terms of the kind of teams that were responsible for managing security, especially network security. Whereas in the cloud, data professionals have a lot more control and remit over what they're deploying. And a lot of the time they are sort of responsible for ensuring that the platforms and the data solutions that they're building are secure. I think eventually, and perhaps we're starting to see this already, there will become an evolution of like a data platform engineer role that's more specific. But I think at the moment, a lot of the onus of network security tends to fall on your data engineers, your data architects, those kind of roles, even your analysts perhaps. So I think it's really important as a data professional to understand the fundamentals of network security, at the very least, just to break down those boundaries between us and the core infra people. Because what I've found is a lot of those core infra people, they've sort of inherited looking after the cloud, but they don't come from a cloud or a data background, right? They come from a very on-prem server kind of background. And when you start talking to them about Spark compute, for example, they glaze over and they don't really know what you're talking about. So I think we have a responsibility to meet them in the middle, at least, and kind of learn a bit of their language so that we can have more meaningful conversations, which ultimately benefit us because it helps get us unblocked quicker, right? Because I'm sure we're all familiar with having to wait for an infrastructure ticket, a firewall rule, or whatever to go in before we can continue doing our work. So that is my, I guess, pitch to you all as to why I think this is important for us to understand as a data person. But now we'll actually move into to some of the technical. So I wanted to just kind of, before we jump in, I guess, orient network security within a larger security framework. There's this concept called defense in depth. People might have heard of that before. It's essentially a cybersecurity approach that uses multiple layers of security measures to protect systems and data. So each layer adds a barrier, making it harder for an attacker to breach. And this strategy essentially acknowledges that no single measure is enough, right? And therefore that aims to reduce the impact of breaches. So networking is one of these layers. Some of these layers, when you're working in Azure, we obviously don't have control over. For example, physical security, we're not responsible for the physical security of Microsoft's data centers. Other things such as the data layer, making sure our data is encrypted, or identity and access, managing roles like row level security perhaps on our data. I think as data people, we're quite comfortable with those security measures. I found as a data person, the layer of this framework that we are most responsible for, that we have the least confidence in, is networking. And so that's why I want to focus on this today, because I think there's a bit of a gap of knowledge there that I'm aiming to address. Okay, so first high-level section then, networks in general. And I must apologise, I'm recovering from a little bit of a cough, so I may have to pause for a few drink breaks. I promise I'm not going silent on you. So if my client asks me to deploy them an Azure Data Platform and they want it to be fully privately networked, the first thing I need to understand from them is, what does their overall network topology look like? Do they have an existing network topology that we're slotting our solution into, or is it completely greenfield? Do we need to help them build and design that network topology? And the first thing I would want to understand is if they're using a hub and spoke topology. And this is because this is kind of the best practice recommended network architecture. So what is a hub and spoke topology? It kind of does what it says on the tin. You have a hub and you have spokes surrounding it. So it's a network architecture where you have your central hub and then you have your spokes or your nodes moving around that. In Azure, this essentially creates a secure network because you use the central hub as a gateway to manage access to your other resources and your data. So a data platform or any other kind of application or solution would typically reside within a spoke network, but it would interact with some central infrastructure in the hub. And we'll come on to kind of what those infrastructure components would be. It's also important to kind of understand what does an organization or a company consider to be a spoke, because different organizations split that up in different ways. An organization I'm working with at the moment is a hugely federated organization, and they have a spoke per line of business per environment, which means they have lots and lots of spokes, hundreds of spokes just in dev. And then they will repeat all of those spokes in test and all of those spokes in prod. Some companies I've worked for have one big spoke network just for dev, and everything goes into that same network. Some companies are sort of a bit in the middle. Excuse me. So that's important to understand. What is the definition of a spoke? Are you slotting into an existing network, or do you need to deploy a new network, right? And understanding where that's fitting in the wider network topology is the first and most important thing that you need to understand. Okay, that is hub and spoke topology. So let's assume that we've had these conversations. We now understand where our data platform is living. Let's say it's going into its own spoke VNet, right? The next thing that's going to happen is we are most likely going to ask whoever is responsible, because maybe we might not have permission to deploy networks. We might need to request someone to provision us with a virtual network. If we ask someone to give us a virtual network, the first thing that they're going to ask us is, how big should it be, right? What's the address space? So again, this is something that often creates a bit of a language barrier, perhaps, where we get asked by a networking person, how big do you need your network? And we're kind of like, well, I'm not really sure. I don't really know how to understand or how to figure that out, right? So there's a few things that I think as data people that we need to be conscious of. Firstly, it's really, really important that if you are deploying your own virtual network, it's important to avoid conflicts, right? You don't want any overlapping address space. Now, if you were deploying a virtual network that was completely isolated and not part of a hub and spoke network topology, you would be fine to deploy whatever address space you want. As soon as you peer or connect up that connect up your spoke VNet to a hub, it all of a sudden becomes part of that whole network architecture. It essentially becomes one big network. And so at that point, it's really important that you don't have any overlapping address space. Otherwise, all the routing is going to get messed up. So if you are deploying your own VNet, make sure you don't have any conflict address space before you peer it onto another network that is then potentially peered onto other networks and vice versa. How do we do that? Well, we use something called IPAM, IP address management. There are different IP address management tools. I think it's useful to be aware that IPAM exists, right? You would hope that your central platform team or your networking team would be using IPAM and they would be able to give you a safe address space to use. But it's always best to check, right? If you're deploying your own network, cross-reference that with whoever is in charge of managing the IPAM and ensure that it's a safe address space to use. If you've deployed a network that is critical, giving them the network address space to add to their IPAM tool, also super important so that somebody else doesn't end up reusing your address space and causing conflicts. As I mentioned already, size requirements, super important, and this really is only a question that we can answer, right? Because only we know what we're using our VNet for. What uses IP addresses? It's primarily compute and interfaces, right? So any kind of endpoint, like a private endpoint, which we will talk about, that uses an IP address, and any kind of compute, obviously like a VM, uses an IP address. Where this gets tricky is when you're using distributed compute. If you are using technologies that utilize clusters like Databricks or Azure Machine Learning and other such tools, clusters can use a hell of a lot of IP addresses. If you think about a node being one IP address, and in fact, in Databricks, a node is 2 IP addresses. And then if you have a cluster of however many nodes, you could be talking hundreds of IP addresses just for one cluster. So in order to understand your VNet size requirements, you need to understand your compute requirements. And in order to understand your compute requirements, you need to understand your data processing requirements, right? How much data do I need to process? How quickly do I need to process it? Because that impacts your the amount of compute you will need, and that impacts your address space. So you can see all of a sudden that just by saying I want to put this in a VNet, it means we have to do a lot more upfront work to understand what we're actually building to ensure that everything is appropriate. Didn't mean to cough into the microphone then. So with sizing requirements, the last thing I kind of want to touch on here is allow for growth. Okay, as I just said, predicting compute, that can be a mysterious art. That can be quite tricky to get right. Always err on the side of caution, allow for growth, allow for scaling, right? Because you never know how your requirements might change, your business requirements might change, and you need to process more data or process it quicker. And so you need to scale up or scale out your compute, which both will require more IP addresses, right? Another way to allow for growth is in terms of services. So if you think about a virtual network, we would typically then split that virtual network up into multiple subnets, each subnet kind of having its own set of services in, logically grouping them. Now, some services in Azure require entire subnets, sometimes 2 subnets, to be delegated entirely for that service. So Databricks is a good example. It needs 2 minimum /26 subnets entirely dedicated to Databricks, and you can't reuse those subnets for anything else. So if I've got a VNet and I decide last minute I want to put Databricks in there, if I don't have 2 spare subnets, I'm screwed. There's no space there. So when I say allow for growth in terms of the size of your subnets within your virtual network, but also allow for growth in terms of the number of subnets, and I would say always leave some spare subnets if you can, to allow for growth in your design, your architecture. Okay, so we've understood our network. We've kind of got our network deployed. It's the right size. We've got the right number of subnets. It's all registered in IPAM, and it's connected up to our wider hub and spoke topology. So that's all good. What do we need to think about next? Well, for me, the next logical thing to think about is ingress and egress. So what is ingress and egress? They are basically fancy words for inbound and outbound. That's all it is. And that is a quote from me just now. It's not a technical definition. It's obviously a little more complicated than that. It's basically from non-trusted to trusted and vice versa. But people tend to use it to essentially mean inbound traffic and outbound traffic, things coming into our environment and things going out. Obviously, when we're talking about networking, we need to understand how things are going to get in securely and how things are not going to get in that we don't want to get in, and vice versa for outbound. So that's the next thing we need to think about. So I want to talk about firewalls and user-defined routes. User-defined routes often referred to as UDRs. So I will be referring to them as those as I go through. We kind of alluded to it earlier when we were talking about the hub and spoke architecture. But as you could probably imagine, in a hub and spoke topology, all ingress and egress goes through the hub. And this provides a level of separation between the spokes and the outside world. The way that I like to imagine this is it's like a bank, right? If you have, we don't really have physical banks these days, I suppose. I might need to update my analogies. But if we had a physical bank that had bank vaults in it, right, you wouldn't have a door to every bank vault on the outside of the building, would you? That wouldn't make very much sense from a security perspective. Instead, there's one main door to the bank. Everyone has to go in and out of that door, and then you are filtered off to your relevant vault once you get inside. That's kind of what happens with the hub and spoke topology. No one should be coming in directly to the spoke, and the reason for that is because we want a way to be able to inspect, monitor, and track who is coming in and out, and that is the job of a firewall, which is kind of the job of like a security guard or a central security system inside the bank, right? We want to check your ID, prove who you are, check that you definitely have access to come in, check which vaults you have access to go to. And if you don't have access to be there, you're not allowed to come in. That's exactly the role of a firewall in a hub and spoke architecture. So typically it would be expected that there would be at least one central firewall in the hub within this architecture, okay? And this means that anyone coming in and out, whether that's via kind of a corporate on-prem network or whether that's from the internet, they're all going through that central firewall. You can take it one step further than that as well. And I've seen a lot of customers do this as well. And so what you could say is, I'm not just interested who can come in and out of the bank front door, but once they're inside the bank, I also am interested whether they're moving between different vaults, right? Some people say once you're in, do what you want, and that's enough for them. But a lot of people, if you're in Vault A or if you're in a particular VNet spoke, if you need to go to another spoke, you have to go back via the hub and check in again and prove that you're allowed to go to that other spoke, that Vault B, right? So to achieve this, we can implement specific routes. We can implement specific route tables. I think in the US you call them routes, which endlessly confused me. I was having a conversation with someone for a good 10 minutes before we realized what each other was talking about. So I apologize if that's confused anybody. So adding a route table to a subnet essentially forces or redirects the network traffic to a specific location. And this is important because you can kind of think of network traffic like water. It will always take the fastest route. So if you're trying to go from one spoke to another and they're connected, it will just go to that other spoke, right? But if you want it to go via the firewall and be registered, we need to have a route table that forces it to go there. Now you'll notice inside this route table, the next hop IP address is the IP address of the firewall. So we're forcing it to go to the firewall will check it, and if it's allowed to go to where it's meant to go, it will pass it through. So this is something that we need to be aware of as data people, because if we're working inside this spoke over here, blissfully unaware, if we're trying to connect out to various services, we need to know what is in between us and that other service, right? Are there firewalls? Are there routes that we should be adding? What does that route look like? Yeah, I always like to think of it like an actual journey. Yeah, if I know my starting place and I know my destination, but I've no idea what's in between, how can I build a route from A to B? There might be water, there might be cliffs, there might be huge drops. You know, I can't prepare for that journey. I might need to build bridges, I might need to climb over walls, I might need ID to get through checkpoints. And that's how networking routes work as well, right? So I think as a data person, it's really important to have at least an awareness or a bit of an understanding. What does the network landscape look like that you're operating within? Because I guarantee you won't just be working within your spoke. You will be wanting to connect out to various data sources, maybe export outcomes out to BI tools that sit in other networks. So I think it's a really important thing for us to understand. Okay, so we talked about firewalls, we've talked about route tables. The next thing I want to talk about is this little blue shield icon here, which you may or may not recognize. That is called a network security group, or a NSG. And these are really important for us because if we're responsible for sort of setting up our platform, this is absolutely something that would be within our remit. It would be within our responsibility to set up and configure. So it's important that we understand what they are and how we set them up. So I've got my hub and spoke architecture example here. I've made my hub sort of smaller in the bottom right there, and I've made my spoke bigger because the spoke is kind of the focus here, but it's essentially the same architecture. Now, a network security group are just mini firewalls. That's all they are. They're mini firewalls for your subnets, and it basically allows you to specify, allow and deny inbound and outbound rules based on IP addresses, ports, and protocols. Now, why is this helpful? Well, it enables us to restrict network traffic at a more granular level. We can restrict network traffic at a subnet level, which provides even more segmentation for our network and for our solutions. So I've got an example here. Let's say we have a SQL database, right, in the cloud, and I've then got a server, VM, that's running some kind of front-end application which is interacting with the server. Now, I might want people to be able to log into the server and interact with the application, which in itself implements its own maybe row-level security, perhaps, for that user. But I don't want the user to be able to log straight into the database directly. If I put those two things in different subnets, as well as identity and access management, I can also put network controls in place. So if that user tries to log in to that VM, the network traffic will hit that NSG. It'll go through the hub first, provided that that firewall is okay. It will be forwarded on to our spoke, to the specific subnet, and then we will have an allow rule on that NSG that lets that user in. Similarly, if they tried to connect to the SQL database endpoint, the traffic would be forwarded to that NSG on that subnet, and we can have a deny rule that we could say anyone coming from on-prem is not allowed to access this subnet. So you can see how this can be a really powerful tool for adding another layer of security, thinking back to that defense in depth cyber security approach we talked about at the beginning. And this is a tool that we have as data people. If you're responsible for deploying your resources, this is something that we can really leverage to add additional layers of security. Now, I've talked a lot about kind of checking that things are allowed to come in, maybe stopping things from getting in. And when you're talking about security and designing a secure platform, it can be really easy to get bogged down with locking everything up. And it's very easy to forget about how you're actually supposed to get in. And true story, and I'm sure lots of people have done this as well. I've once deployed, one of my first platforms that I ever deployed. I was so proud of how secure it was, how locked down it was, until I realized that I couldn't get in and none of my developers could get in, right? And obviously that is a definition of secure, but it's not a useful definition of secure. Okay, so thinking about how you actually want to let people get in a secure way, because I guarantee if you make it difficult for people to do what they need to do, people will find loopholes, and that leads to more risky behavior, which could lead to more breaches. So baking that into your design, how are people going to develop securely? How are people going to get access to the lake or their different endpoints, different UIs that they need to access? I'm not going to spend too much time on this slide. I'm sure we're all familiar with the different ways that you can achieve this, but just to kind of rush through a couple. So virtualization tools like Cloud PC is a really common one these days. You've got your older ones like Citrix as well. You've also got newer tools like DevBox, which are more like pre-configured workstations. You've got Bastion. I don't know if many people use Bastion anymore. People tend to use Azure Virtual Desktop instead. It kind of creates a secure host for users to connect into. It's like a front on top of other VMs that they can use to jump into the network. And then you've got your just good old-fashioned jump box, right? So various different ways to kind of embed users into the network to ensure that they have connectivity. No right or wrong answer, really. You just want to make sure that you have thought about it, basically, when you're in the architecting phase. That's the main takeaway message there. You don't want to end up like me, looking like a fool. Okay, so we've thought about how things are going to get in, how things are going to get out, how we can manage, firewalls and network security groups and different routes. So I think we're pretty good on that front. We're pretty happy with how that's all going to work. Now we need to turn to our actual platform, right? At this point, we haven't actually deployed a platform. We've just been thinking about the network topology and deploying kind of the associated bits and pieces and making sure that our environment is kind of connected up to everything else. Now, when people say they want a fully privately networked data platform in Azure, it's kind of a given that we will end up talking about Azure Private Link. So I want to talk about that because it's very common. Nearly all of my clients use this now. If you're wanting to do private network in Azure and you're using PaaS, you will need to use Azure Private Link. So what is Azure Private Link? Azure Private Link itself is the name of the Microsoft technology, and that technology underpins Azure Private Endpoints. Okay, people often use the two phrases interchangeably. They're related but slightly different. Azure Private Link is kind of the concept. It's the generic technology name, and the endpoints is like the actual thing that you deploy. An Azure Private Endpoint can be used to securely access any Azure PaaS resource instead of using the default public endpoints that ship with those PaaS resources. So private endpoints are not for things like VM, they're not for IaaS, they're also not for SaaS, they're for PaaS resources. So you are reliant on Microsoft providing you with private endpoints that you can use, but all the big first-party PaaS resources have private endpoints available for them, and some of the third-party ones as well. So any public endpoint of a resource can be replaced by a private endpoint. It's important to think of an endpoint as not being one-to-one with a resource, and we'll explore that a little bit. But a storage account is a good example. So a storage account is a resource, obviously, but it has multiple endpoints. It has blob, DFS, file, queue, table, and web. I think it has 6. So when you're deploying a private endpoint, you need to make sure you know which public endpoint you're swapping out the private endpoint for, right? How do they work? They essentially bring your service into your VNet by associating a private IP address from your VNet to the endpoint of that resource. What do I mean by that? In fact, before we build out the diagram, I kind of want to just use a bit of analogy. So let's go back to the bank example. Let's think about the bank as a PaaS service, right? It's a service that I want to consume. And let's say I live across the road from the bank. In this example, the bank is the PaaS resource and my house is my VNet. That's my safe, secure place. Now, if I want to use the public endpoint of the PaaS resource, i.e. the front door of the bank, then, then at present, I have to leave my house, leave the security of my VNet, walk across the street and enter the front door of the bank. Now, let's say I live in a particularly dangerous area, and every time I leave my house, there's an 80% chance I get punched in the face. I'm probably not going to want to leave my house, right, if there's such a high chance of being punched in the face. So how can I achieve this more securely? Well, what would be great is if I had a magic portal inside my house that when I step through it, I'm in the bank and I never have to leave my house. That's what a private endpoint is, right? It brings the service into your VNet. It creates a new doorway, a new gateway for that service that's only available to you, and it's inside your network, and you don't have to leave your network to get into the service. That's what it is. And so when people talk about bringing a service into your VNet or putting a service in your VNet, that's actually what they mean. So how does this work from an architecture perspective? So we've got our hub and spoke. We've got MySQL database deployed, or MySQL server. I think the private endpoint is the private endpoint connected to the database or the server? It's connected to the database. So we've got our hub and spoke architecture, and let's say someone within the network, they might be on-prem, they might be on the corporate network, which is perhaps connected to the hub via an express route or a VPN. And then that's the hub is connected to the spoke. So it's all one big network that's connected together. So they try and access the endpoint. That's all good. It's a private IP address that they're trying to navigate to. They're inside the network. And so that private IP address means something to them. And so they're able to get in. If there's someone outside of the network, they will be trying to connect to the public endpoint of the resource. And they won't be able to get in if we've turned the public endpoint off. You can actually have the public endpoint turned on whilst you have a private endpoint, but I would never recommend having that set up. If you're using private endpoints, you want to turn off the public endpoint. So you can immediately see how this is way more secure. It basically saying you have to be inside the network in order to access these resources. And so most people say they want their platform in a network. This is what they mean. Now, unfortunately for us, just deploying a private endpoint resource is not sufficient to achieve this behavior that you can see on the screen. There is another piece of the puzzle, and that piece is DNS, which I know everybody hates. But I'm going to spend a little bit of time talking about it because, again, I think as a data people, it's really important for us to have a foundational understanding of DNS because 9 times out of 10, when something's broken, it's networking, and 8 out of those 9 times, it's because of DNS. So knowing at least what to ask for accelerates those debugging conversations with your networking team. So little bit about Azure Private DNS then. So as I said, Private Link does not work without integration with Azure Private DNS. It's possible to have a custom DNS solution, but the Microsoft recommended route is to use Azure Private DNS zones, which are an Azure resource. So if I bring up our same architecture, it's exactly the same as we had before, but we now have this concept of a private DNS zone resource, which you'll notice lives in the hub. And I'll come on to that in a minute as to why that needs to live in the hub. What is a private DNS zone? Well, I like to think of it like a huge public phone book that lives in the sky. Again, perhaps I need to update my analogies. No one really uses phone books anymore. But essentially, it allows us to look up associated public IP addresses with domains. Now, sorry, that's public DNS. So public DNS is the huge public phone book that lives in the sky, right? We use it every day when we're Googling or whatever it is that we're doing. And it basically, because computers like to talk in IP addresses, but humans like to talk in domains. If we type in www.google.com, the computer needs to translate that to an IP address in the background, and it uses public DNS. It flicks through, finds google.com, and finds the associated public IP address, and then it returns that to your computer, and then it tells your computer where it needs to go. A private DNS zone is a smaller private version of that, and you can think of it like the contacts list in your phone as opposed to a public phone book. So the contacts list on your phone only has the names and numbers that you care about that are private to you, and no one else can use that unless you give them access to your phone, right? That's what a private DNS zone is. So it, instead of containing mappings from domain names to public IP addresses, it exclusively contains mappings between domain names and your private IP addresses, okay? So what happens actually if we expand the previous architecture diagram? When the user tries to access this database endpoint, that will submit a DNS query, which will get picked up by the relevant DNS zone. The DNS zone flicks through its pages and it says, you're trying to get to this domain, you want to go to 10.0.1.8. The computer that you're on will say, okay, I'll take you to 10.0.1.8, and we're back where we were before. The user's able to get in. Happy days. The person who's on the outside, they do not have visibility nor access to the private DNS zone. So when they try and hit the same domain name, it will be, the DNS query will be picked up by public DNS. And the public DNS will return one of the many public IP addresses that are associated with SQL Database Endpoint in Azure. This is a genuine public IP address. You can find all of the public IP addresses on the Microsoft website. You can download a huge JSON file, which if you're a nerd like me, you just have saved, and you can find all the different IP addresses available. That will then take them, of course, to the public endpoint, which we've turned off, and they won't be able to get in. So that is how that behavior works. It's because of DNS. So how do we configure those DNS zones? How do we deploy them? How do we set them up? Well, a little bit about DNS zones first. Private DNS zones should be part of a central DNS solution. Now, this is really crucial to understand as a data person, because I have seen many data people try and read the private link documentation. They understand that they need to deploy a private endpoint. It then tells them to deploy a private endpoint. You need to integrate it with a DNS zone. And actually, Microsoft is a bit misleading in the portal, because if you go to create a private endpoint, it will ask you, do you want me to create a new private DNS zone? And you think, oh yeah, go for it. Automate it for me. You set it all up. That's a big no-no in a hub and spoke topology. There are limitations that I won't go into, but essentially if you have multiple sets of private DNS zones all over the place and they're all connected to the same networks, everything breaks. So it's really important to have a central set of private DNS zones. And that leads us on to our next point. When I say set of DNS zones, it's expected that you will have one per domain. So you will have a SQL database one, you will have a Key Vault one, you will have a blob one, you will have a DFS one. All the different domains that you want to use private link for, there will be one private DNS zone in the hub, and that will contain DNS records, which we'll talk about in a sec, for everything in your entire enterprise. Very scary resources, risky resources. You don't want to be giving people access to these willy-nilly. As data people, we probably will not have access to these private DNS zones. So it's important that we know we need to ask someone, can you connect our private endpoints up with these DNS zones that I presume already exist? If they don't exist, you need to tell them which domain you want a private DNS for. So again, having this fundamental understanding helps us to have more useful conversations with the people who are responsible for the custom DNS solution. as I mentioned, we have one per domain, and those domains have specific names. So the private DNS zones have very, very specific names that they have to have, and that's how it figures out where to send which DNS query. That is all documented. You can find a big list of all the DNS zones and what they should be called. And we've already touched on they're reusable. So the Key Vault private DNS zone will be reused by all Key Vaults and all associated private endpoints in your entire enterprise, regardless of environment. I'll skip over that. DNS records. So I mentioned that a private DNS zone is like your private contacts list in your phone. Now, when you get a new phone or a new SIM, your contacts list is empty. So is a private DNS zone. It's actually a very, very simple resource. When you deploy it, you just give it a name and that's it. It's actually a global resource, so you don't even give it a region. And it's just an empty list, basically, when you deploy it. You are responsible, or someone is responsible, for adding what we call DNS records. And that is the thing that provides the mapping between the name and the IP address, right? The domain and the IP address. So in this example, I've got an A record down here, which is specific for my SQL database and specific to that IP address. And you can see, if I click into it, it's got the fully qualified domain name, the private link version, and the IP address. So that is what the DNS query picks up and returns whenever you question it and say, where am I going? What IP address am I going to here? That's how it knows what to return. Again, so your private endpoints will not work unless you have an A record in a correct private DNS zone. And this is where data professionals often fall down. They try and deploy a private DNS zone and get confused with the DNS setup. So if you know that you need to ask your platform team or your networking team, hey, I've deployed a private endpoint, please can you integrate it with the central DNS? Please can you add an A record in this private DNS zone? That accelerates that conversation so much quicker. Okay, so I think we're doing okay for time. So we're on to the last section now. So I've kind of covered all of the high level concepts and technologies and tools that I think are at our disposal and that we should use. Now we're ready to actually deploy some data platform components, right? Now, obviously, I'm not going to talk about every possible data platform component under the sun, but I wanted to touch on a few of them and common pain points that I found, because whenever you decide to do something in a private network, it kind of opens a bit of a can of worms, and something that you thought was quite simple to do and configure and deploy suddenly becomes very complicated. And so there's other things that you have to consider. You can't use a lot of default settings and components. And these are the things that I try and advise my clients of up front so that they are aware it's not going to be as simple as when you're not using private networking. So the first thing I want to talk about is Azure Data Factory. We'll talk about Fabric as well, but I want to talk about essentially the concept of integration runtimes, which, for anyone who doesn't know, is essentially the compute used by Data Factory, right, of how to connect to your data sources, how to lift and shift data, process data. It's called an integration runtime, and the default Azure hosted IR, or integration runtime, obviously will not have access to any of your privately secured resources. So if you're trying to pull data from a SQL database that's behind a private endpoint and write it into a storage account that's also behind a private endpoint, the default Azure IR, it's serverless, okay? It doesn't have access to any of your privately networked resources. It's not, the compute is not inside your network. So how do you handle that? Well, there's